Let us run the previous simulation again and observe the waveforms. After proper magnification, we can see that during turn on time, that is when the PWM pulses are high, when the primary winding is getting charged with its current increasing linearly, and we can see that the output voltage and output current are constant. During turn off time, the current is 0 in the primary winding, and on the secondary side of the output side, the load voltage and current gets reversed and reaches 0 at the end. This is because the magnetic field that was developed in the transformer during turn on time gets discharged into the load during turn off time. We will need to find some solution to two phenomena that are occurring here and which are undesired. One is the voltage reversal on the output side, which can be solved by interchanging the connection of the transformer secondary and load. So let us do that and change the winding terminals. As we can see, the output voltage and output current has become positive now. Another problem is that output voltage and current are not constant, rather it has a lot of spikes in them. Another issue is that the load and the output side are only conducting during off time. During on time, there is no flow of current in the load. Both these problems can be rectified by placing a capacitor at the secondary side of the transformer. This capacitor will store the energy during the turn on time and will release the energy during turn off time. Hence, the capacitor can support the load during on time and can also mitigate the ripples in the output voltage and current. Before placing the capacitor, let us place a blocking diode and check if there are any changes in the output waveforms. It can be seen that there is no change in the waveforms after placing the blocking diode. We will have to place a blocking diode between load and the transformer secondary because the energy stored in the capacitor during turn on time will also go towards the transformer, which is undesired. The energy should only move towards the load. In order to stop this phenomenon, we will have to place a diode between transformer and a capacitor to block the movement of energy from capacitor back to the transformer. We will place the diode in between but will disable its measurement port. Let us also add a capacitor of 100 microfarad and observe the waveforms now. one can see that now the voltage is fairly constant. The variation in the voltage is less than 1 volt and the variation in the current is less than 5 milliamperes. So the placement of diode and capacitor has solved both the problems and we have attained a fairly constant voltage and current in the output side. So this much will be for today guys. With today's session, our textbook explanation of flyback converter is over and in the next video we will start the process of prototype development. Thanks for watching. Drop a like if you found this video helpful. Leave a comment if you have any query regarding the topic. And don't forget to subscribe and share this video with others.